Hello and welcome everyone. In today's video, we are going to look at a very important infinite series expansion which is required for class 11 and 12 students in many places, especially calculus. So today this is our topic to understand in a deeper way, because I feel that when I was in class 11 and 12, I did not understood. I just used that fact, but the deeper understanding was not there. So let's move ahead. As you can see, the heading is infinite series expansion here. Let me full page, yeah. So first of all, let me write down what are the infinite series we are going to look at. The first one is sin x, and I am writing the expansion. Maybe you already know, but I will tell you much more important thing, and I'm sure you will understand this one in a much better way. Okay, and x minus x cube by 3 factorial plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial plus so on dot up to infinite. So what is the important thing that you can look at here? Everyone, just x power is here 1, it is power is 3 here, power is 5 here, power is 7 here, and in the denominator it is 3 factorial, basically the same number of the power. It is 5 factorial, it is 7 factorial. So this is very interesting. Okay, so if you look at, everything is odd here, and this is one of the reason that sin x function is automatically is also odd. So it is your odd function, and this side everything is odd, so odd function. I am not sure that whether you have the idea of odd function or not. So powers are odd, that's the reason it is odd, and sin x is our odd function. So both the sides are equal. So I'm sure you have understood. And from where this expansion is coming, everyone, this is actually coming from Taylor's theorem. Maybe you have heard the name, and you are going to learn this one in higher studies. Taylor's theorem, or somebody is saying that it is from Maclaurin theorem or law. So these are the two people, one is Taylor and one is Maclaurin. Okay, they talked about this kind of expansion, infinite expansion, in much more detailed way. So from Taylor's theorem you will understand this one, but right now it is our scope of the syllabus. It is just out of our radius, so we won't talk about Taylor's theorem. If you are interested, you can search it by yourself. So what is my technique here to make you understand? The first thing is, if you substitute at x equals to 0 both the sides, 0 both the sides, okay, sin 0 degree we already know that, which is 0, and if you put the value 0 here, everything is 0, so ultimately this is also going to become 0. So this is a very basic, it is a very naive way, okay, so by which you can convince yourself that okay, no, this is valid, left hand side is equals to right hand side for x equals to 0. So maybe this is true, but still you have a doubt whether it is correctly true for all other values or not. So that's why, what is my technique? My technique is, with the help of graph, I will try to make you understand, okay, that both the graphs are same. So just try to understand, everyone. What I'm going to do, I'm going to draw this side graph and the graph of sin x, which is very simple, and I will show you that both the side graph is exactly same. So let me take you that tool, interesting tool. That tool is our GeoGebra. So let me draw first of all sin x. This is our sin x graph, and I'm sure you already know this is your this is sin x. At 0 the height is 0, at 90 degree height is 1, that is maximum value is 1. At pi, which is here, pi the value is 0, you already know. At 270 degree, which is 3 pi by 2, height is -1. So these are the basic things about the sine graph, and it's a periodic graph. There is no end of the graph basically, so that much is not required. You just know the basics around from 0 to 2 pi or maybe minus 2 pi to 2 pi. That is sufficient for JEE mains and advanced. So now next what I'm going to do, I'm going to write our infinite series. What is my infinite series? X minus x cubed by 3 factorial. So let me move ahead there. X minus. Now everyone, let me change the color so that it will be easier for you to understand. Let me change the color of this one as blue, and what I'm going to do, let me make it dotted, not line. So this dot will be, I think, good. Okay, so that is the first term. Let me go ahead and write down the next term. X to the power cube divided by 3 factorial. Factorial is there already, plus, let me put enter first of all. Now look at here everyone, what is happening. This blue graph is basically trying to follow the graph of sine. So as you keep on adding, you will understand it will try to follow. Let me move ahead with plus sign, plus x to the power 5 divided by 5 factorial. Look at here everyone. So what is happening? The blue graph, okay, basically keep on dancing in different way, and but ultimately try to follow the graph of sin x. Okay, so as you keep on adding the other terms, let me add the another one. Next one is minus x to the power 7. Okay, just wait. X to the power 7 divided by 7 factorial. So look at here. Right now, if you look at here, everyone, very correctly, this blue graph is basically trying to match with the graph of sin x. So this is a very beautiful explanation of this infinite series. If you keep on adding, you will see this graph is trying to follow. This graph is trying to follow the graph of sin x. X to the power 9 divided by 9 factorial. Look at here. It is beautifully trying to match with the graph of sine. Next term is negative x to the power 11. Next term power is x to the power 11 and divided by 11 factorial. So after that I will not write. You can, if you are interested, you can write it down. You can write down by yourself. Look at here. You cannot differentiate whether the sine graph is there or not. Look at here everyone. If I will zoom in, okay, if I will zoom in, hardly anybody will identify that here only blue graph is there or red graph is there. Okay, so basically both the graphs are exactly same. And this is one of the nice proof, okay, why this expansion is true. So the same experiment we will do with the help of cos graph. Okay, before that let me write down what is the expansion of cos. Okay, so expansion of cos, let me write it down here. The expansion of cos is this one. Cos x is equals to 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial minus x to the power 6 by 6 factorial plus dot 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 so on. And what is the basic difference between sine and cos? In case of sine, if you look at the power of x, it is odd, and in case of cos, the power is even, and that's why it is basically even function. Cos is your even function, this is your even function, so both the sides are exactly same. Okay, some book it is maybe written that x to the power 1 divided by 1 factorial, just to make the symmetry. It is x to the power 0 divided by 0 factorial, you can write. No problem at all. So again the same kind of proof you can do by yourself. If you put the value x equals to 0 both the side, it will be cos 0, which is 1, and it is also 1, so 1 equals to 1. So basically it is matching. So that means this is, I think, is absolutely correct. So still if you are not convinced with this one, so you can try it by yourself in GeoGebra. Let me move ahead. Let me delete all these things. Cosx graph, let me change it to dotted line. This is our dotted line, okay. And next is 1 minus x square divided by 2 factorial plus x to the power 4 divided by 4 factorial, okay, minus. And as you can see, if you start adding the terms, you can see that, okay, this black line or black graph, let me change the color here, this red one is trying to follow the dotted graph, which is our cos graph, okay. So you just try by yourself at home, and the Android application is also available, geogebra.org. So you can try even when you are sleeping in the bed. So it's very easy, okay. So you just keep on writing few terms, maybe up to 7-8 terms. You will see how nicely this red graph, okay, is trying to follow the graph of actual Cosx graph, which is our dotted graph here. So I hope you have enjoyed this video, and if you want to give any suggestion, you can write definitely on the comment section, and I will try to make this kind of interesting video for 11 and 12 student where the difficulty generally are there. So thank you everyone. We will meet in the next session.